We continue with another concept of differentiation, and that is differentiation of inverse trigonometric function. When we started this course, we have explained the differentiation of the basic trigonometric function, the sine, the cosine, and the tangent. Now we are dealing with their inverses. How do we get the differentiation of each of them? We have to find the derivative of the inverse of sine, the derivative of the inverse of cos, and the derivative of the inverse of tan. So let's start with the first one. How do we get the derivative of this? We are given a function or the inverse of a function of sine s. Then we have to find its derivative. We have to find the y, the s. The first thing you have to do, you want to work a step-by-step approach on how this derivative is gotten. Although we know the derivative, but we want to work it out. How was the derivative achieved? Now, the first thing we can do is that we can express this function. We can say have a dependent variable y to be equal to a function of x, which is this. That's the first step. So the next step is to get rid of this inverse by multiplying both sides with sine. So we have sine y is now equals to, this one is arc sine s multiplied by what? Sine. We are multiplying both sides by sine. Also further, we can express this as s all over what? Sine multiplied by what? Sine. This cancels this. Then that means sine y is equals to x, or you say x is equals to what? Sine y. So we have expressed x as the what? The dependent variable on y, which was the inverse of this. So we are trying to find the y, the x, but from here we can get our the x, the y, and that is what? Cos y. But we are looking for the y, the x, then we can take the inverse, that is the y, the x, and that is 1 over what? Cos y. 1 over cos y is what we get here. But this cos y is an introduced variable. Then we have to what? Get rid of this cos y. How do we get rid of this cos y? We can use the fundamental trigonometric ratio, a function that we know to be what? Cos square y plus sine square y is equals to 1. Then we can make cos square y the subject. We can say cos square y is now equals to 1 minus sine square y. We are here now, cos square y is equals to 1 minus sine square y. Then we can make cos y the subject, that's square root of 1 minus sine square y. Now, from our previous equation, that's not what we are interested in. We were told that s is equals to sine y. This is what we are interested in. S is equals to what? Sine y. In this equation, we can express this sine square y as x because s is equals to sine y. Then coming back here, then we have square root, since s is equals to what? Sine y. Then we can say cos y is now equals to square root of what? 1 minus s squared. So we have been able to express this cos y as a function of s. Then going back to the equation we were given, which was the y, the x, and that is equals to 1 over cos y, and that is also equals to 1 over square root of what? 1 minus s squared. It means that if you are looking for the inverse of this, the derivative of this inverse of sine s is 1 over square root of what? 1 minus s squared.